Hello everyone. We will try to cover error function and complementary error function using mathematics. Okay. So first we have to know the basic definition of the error function. So basic definition of that error function is simply your 2 by root pi 0 to x e to the power minus u square du, and the complementary error function is somehow 1 minus er f of x. Okay, so now what we have to do, we have to just try to correlate this complementary error function in terms of integral form, and we will discuss how we have to do with the complementary error function with mathematics. So I will start with this complementary error function. So how the complementary error function can be written in terms of integral form. Okay, complementary error function in integral form, how we have to write complementary error function in integral form. So the first thing, how to write the complementary error function into its integral form. Okay, so we are just writing the er f of c x er okay er f of er er f of c of x equals to 1 minus er f of x. Okay, now what I am doing, 1 minus this term we know, 2 by root pi 0 to x e to the power minus u square du. Okay, now after that what I am doing, I am just writing this 1 as a 2 by root pi 0 to infinity e to the power minus u square du minus 2 by root pi 0 to x e to the power minus u square du. Okay, so it is very difficult at that instant to think about why 1 is written as this one. Okay, so that thing first I will to cover. Okay, so actually error function is there something. So this one, if we have to solve this error function, okay, so suppose how I am writing this one. Okay, so before that I have to do some mathematics for this. So I am writing here. Okay, so what exactly we are doing, if we have to find some integral, say minus infinity to infinity e to the power minus x square dx. Okay, this one is some integral that you have to find. Okay, to solve such integral we have to use some concept in which we can write this one have the same value. Okay, means this integral and this integral is somehow the same. Okay, so we have to use the concept of double integral here. So we can write this as a I s square minus infinity to infinity minus infinity to infinity e to the power minus x square e to the power minus y square dx dy. Is it okay? So this one is the, we have to use the concept of double integral, because if we go for this using the single I for this one, it is very difficult to solve such exponential problem. We have to go for the double integral by using this concept I square minus infinity to infinity okay. So now what I am doing, this can be written as minus infinity to infinity minus infinity e to the power minus of x square plus y square dx dy. Now we have to convert this one with a polar coordinate by putting x equals to r cos theta, okay, and y equals to r sin theta, okay. That will give the value for the, okay, so for the limit the r value, okay, for the timing, this one is x and y. So this r value is your r value and theta value. So r value will be vary from 0 to infinity for r. R value will vary from 0 to infinity, but theta value will be from 0 to 2 pi, okay, from theta, okay. This theta will up to this one. So theta value 0 to 2 pi. So we can write as e to the power minus r square, okay, x square plus I, and for the dx dy, what I am writing, r dr d theta, okay, because we are just converting the what we can say, we are just converting the Cartesian coordinate to its corresponding polar one, okay. So how I am writing, instead of the area dx dy, we are writing r dr d theta, okay. So I will prove this one, why I am writing this term as a minus r dr d theta, okay. So for this purpose, what I am doing, there is a term dx dy, okay. So basically what we are doing, the term dx dy, there is a Jacobian, okay, to convert the transformation of coordinate, okay, in terms of r theta is written as dr d theta. This formula is valid for every transformation, okay. Jacobian very means advanced concept, where this Jacobian can be written as del x by del r and del y by del r, and now next one del x by del theta and del y by del theta. This one is basically the formula dr by d theta. Now if we put del x by del r, by x is your r cos theta, so we can write this as a del x by del r cos theta, and this would be sin theta, and del x by del theta is minus sin theta minus r times of sin theta, and this one equals to r of cos theta, okay. This one is determinant form. So it should be your cos square theta r cos square theta minus should be plus r sin square theta, okay. So it should be your r, okay, and it is dr d theta, so it should be r times of dr d theta. So that's why I am writing this one e to the power minus r square r d theta r dr d theta. Okay, that's why we are just writing in that fashion. Okay, so now we can easily integrate this one by making r dr d theta. Okay, so r dr d theta, now we can do first one for the integral 0 to 2 pi d theta into 0 to infinity e to the power minus r square r dr. Okay, so this integral value will be theta, means it should be 2 pi, and this should be suppose 0 to 0 to infinity e to the power minus r square r dr. Okay, so if now we have to solve this one, so for the time being what I am writing, r square equals to z, so it should be twice r dr equals to dz. So r dr equals to dz by 2, so we can write 2 pi into, take half common, r value 0, so it should be 0 to infinity e to the power minus z dz. Okay, so this integral is very easy. Okay, so after that what I am doing, okay, I am writing here 2 pi by pi, so this 2 should be cancel. Okay, this 2 should be cancel, and it should be e to the power minus z dz, so it should be integral e to the power minus z by minus 1 infinity to 0, so the value become minus pi, take minus e to power minus infinity minus of e to the power 0, we can write. Now we have to find the value of e to the power minus infinity. Okay, so we know y equals to e to the power x. Okay, where x infinity it will, like, and when x tends to minus infinity, this value tends to 0, so it value becomes 0, so it value minus pi, 0 minus 1, so this value will become pi. So now we have find the value of I square, not I, so I value is somehow root pi. Okay, so we can say that this value I value is nothing but simply root of pi. Okay, and if we plot this, what we can say, I equals to what we can say, e to the power minus x square, or y equals to something, it is nothing but simply a bell shape thing. Okay, this one, and this value, if we take the integral for minus infinity to infinity, it value will give you root pi. So for the integral 0 to infinity, it should be root pi by 2. So root pi by 2 value, so we can say 0 to infinity 2 by root pi, 0 to infinity. So that's why initially we have written, means, okay, I am writing here, zero to infinity e to the power minus u square du equals to pi by 2. So this 2 by root pi, 0 to infinity e to the power minus u square du is somehow equals to 1. So that's why instead of this one we have written this value. Okay, so now for the time being I am saying this one as equation number 1. Okay, is it clear why I have written this one 2 by root pi 0 to infinity e to the power minus u square? This one is the extended notation for 1. If you integrate 0 to infinity e to the power minus u square du, it should be root pi by 2. Okay, so now we have to use the equation 1. Okay, equation 1. So what we have to write again from er f of c of x equals to 1 minus er f x. Now this value should be 2 by root pi. For 1 I am writing, already I have derived, and it should be 0 to infinity e to the power minus u square du, and this other one is also 2 by root pi. The value should be 0 to x e to the power minus u square du. Okay, so this value can be by taking common 2 by root pi. Then can we write 0 to infinity e to the power minus u square du plus 2 by root pi. I will tell why I am writing plus. Now we are changing the limit, minus u square du. Okay, so actually there is a very simple formula, a to b integral property. Then we can write minus b to a fx dx. Okay, I am highlighting this one, this one. This one is the simple property that we are using. Okay, so after that what I am doing, the same expression can be written as 2 by root pi. Now what I am doing, we are writing from x to 0 e to the power. Okay, there is no need to write this one, already we have taken the common, minus u square du. Then after it should be plus 0 to infinity e to the power minus u square du. Okay, now x to 0 and 0 to infinity, so it should be simply written as 2 by root pi x to infinity minus u square du. So this one is the complementary error function representation, okay, in form of integral. Is it okay? This one is the representation of that error function in terms of the corresponding integral. Okay, now okay, now I will, okay, so this is all about the simple conversion of the complementary error function into its integral form. So in the next video I will continue with the same concept, all this concept. Then we have to find the how error function, that is our okay, how the error function er f function is value for x0 it should be 0, er f of infinity is y1, that I will cover in next lecture. Okay, so thank you for watching this video. Okay, thank you.